Now, before we do that, let's have a look at an example first. So this one will give us some formal definition of reliability terms. For example, the mean MTTF. What is MTTF? MTTF is mean time to failure. Okay. And what time will 50% of resistors be expected to fail? This is a median time to failure. That is mean time to failure. Okay, median means 50% of the part. Now let's first have a look at this example. So a company manufactures resistors, and the lambda equals to 0.15% per K. Okay, so what is this special unit that people use in reliability? This is percent per K. Percent per K is actually percent per 1,000 hours. So if you put the resistor into the oven and you do the test, okay, you see how they're going to fail. And this is the accelerated live test. And this is a lambda equals to 0.15% per K, means 0.15% per 1,000 hours it's going to fail. This is a failure rate. Okay. And if we have 1% per K, 1% per K, what does this mean? This is actually an expected rate of one failure for 100 units. Operating 1,000 hours. Okay? So this is physical interpretation of this unit. 1%, that means you have one. Failure rate is one failure out of 100. That is 1%. And operating thousands of hours. 1,000 hours. So the first question, what is the probability that a randomly chosen resistor will survive 20,000 hours? So we were given lambda, obviously they were assuming an exponential distribution here. What is the probability that a randomly chosen resistor will survive 20,000 hours? This is RT, right? So the first one is RT. RT equals to 2,000, or not 2,000, 20,000. This equals to exponential minus lambda t, but our lambda is 0.15% per K. So percent is 10 power minus 2. Per K is 10 power minus 3. So if you add these two together, the lambda is actually exponential minus 0.15 times 10 power minus 5. You see? Why minus 5? Because percent is 10 power minus 2. And you have per K. Per K is 1 divided by K is 10 power minus 3. Okay? If you put these two together, it's actually 10 power minus 5. That might make sense? And the T is actually, we should not, right here. T is 20,000. So it's 2 by 10 power 4. This equals to exponential minus 0.3. So you will be able to get the probability. 97%. Okay. Second, what's the probability it fails in the next 35,000 hours? So this is a memoryless, because you want to see probability t less than 35,000 given t has already been greater than 20,000. So this is actually equals to probability. We have denominator, that is probability less than 35,000 greater than 20,000 divided by probability t greater than 20,000. Okay? So what is this? This is actually f 35,000 minus f 20,000 divided by, this is r 20,000. So if we put the exponential distribution in, this later it should be equals to 0.051. So next one is mean time to failure. So for exponential distribution, what is the mean time to failure? What is the mean? 1 over lambda is actually the mean of the exponential distribution. So mean time to failure is actually just the 1 over lambda. 1 over lambda equals to 1 over 0.15% per k. So it's by 10 minus 5. This equals to 66 point, actually 667 hours. Yeah, pretty reliable, this resistor. Right? Now, next one is median time to failure. What is median time to failure? Median time to failure is 50% of the resistor be expected to fail. That means we are counting how many of them failed at that time. Okay. For this one, it's actually all the failure times, right? Expected failure times. If you have a population, it's basically the average, right, of all the lifetime. But this one is actually what time that half of the product will fail, which is different. Median is different from mean. Am I making sense? So F, you want to find the time that is 50% is going to fail. So this equals to 0.5. So F should equals to 0.5 because 50% of them will fail. So this equals to 1 minus exponential minus lambda t 50%. Obviously, based on this equation, we're trying to solve for t 50%. But we know this lambda already, and we have this equation, and what we want to solve is t50. t50 is our target. So now it's just a matter of solving the equation. Solving the equation is 0.5 equals to 1 minus exponential minus 0.15 times 10 power minus 5, and then times t 50%. T 50% equals to hours. Okay. So T 50%, if we have this right here, so exponential minus lambda T 50% equals to 0.5. If we take the log on both sides, we will have right? So if you take the log, and then we're going to have lambda. Lambda is actually equals 0.693 over lambda. No. We're going to have T50. T50% is actually equals to over lambda. So I think some of you cannot see it. So as you may notice, mean time to failure. This is mean time to failure. This is a median time to failure. So if I want to summarize this more clearly, that is median time to failure. It's actually equals to 0.693 over lambda. So median time to failure and mean time to failure, which one is bigger? Mean time to failure. Okay? Because this is 1 over lambda. That is 0.693 over lambda. Okay. That means 50% of the product actually achieve failure earlier. Okay. Right? And by the time of mean time to failure, you have more than 50% of product fail.
Because the tail is extended. So
yes.